Good afternoon. Welcome to this month's Lunch and Learn entitled Splunk Common Information Model. We appreciate your time today and believe that you will come away with additional tools and knowledge for working with Splunk on a day-to-day basis. Today's session will be delivered to you by Eric Holsinger, who is a Splunk architect and a member of our customer experience team that delivers Splunk expertise on demand to our customers and supports our Atlas product that helps you get the most out of Splunk. If you have any questions along the way, please post them in the chat and we will get to them. And now I'll hand it over to Eric.
All right, thank you, Steve. Like you said, my name's Eric Holsinger. I'll be giving the presentation today. And the topic for today is the Splunk Common Information Model, something that you'll often hear abbreviated as Splunk CIM, C-I-M. I will probably switch between those two names today. I'll try to use Common Information Model as much as I can, but saying CIM is just so much easier. So let's go ahead and look at the agenda. So we're going to start off going over a bit about data models. You really can't talk about the Common Information Model without talking about data models. They are kind of one and the same. Then we will kind of specifically go into the overview of the CIM. We will look at the Common Information Model add-on. Then we're going to kind of go over a live demo of how to install that onto your system, a little bit about normalizing data and getting data CIM compliant, and then searching CIM data models within Splunk. So first off, we'll talk a little bit about data models. So Splunk data models allows for simple and efficient SPL searches that can be used to search across multiple vendor data sets. So it's kind of a way to bring together similar data in one place, despite having different vendors, different sources of the data. If it's similar data that's coming in for a similar purpose, you can group that together within data models and make your searching a lot more robust and simplified. And so why use data models? Like I mentioned, it simplifies searching by enabling a common set of fields and tags so you can search multiple data sets at once. And you can get increased performance through data model acceleration. We'll talk about that in a little bit. And as we're going to talk about later, the Splunk Common Information Model allows you to really quickly adopt data models. And you can allow for simple correlation across multiple log sources. And so that kind of brings us to the Common Information Model, the CIM. And so this is a shared model that Splunk maintains that is used to help congregate similar data together across different technologies. It uses normalization and aliasing to match data across different sources and vendors. And it is very heavily used in Splunk premium apps, especially enterprise security. So as we'll see in a little bit, it's essentially a list of data models that provides, and actually I'll save that for a couple slides. But this Common Information Model is a TA that's free to use on Splunk base and provides data models for commonly ingested dataset types. So here's what I was mentioning. These are the data models that are included in the CIM add-on. So you can see we have things like authentication data, data access, email data, network traffic, intrusion detection, web data. So these are the ones, the data models that come with the CIM data model. And as you can see, you can kind of relate these back to data that's coming into your environment and how you might use that, how you might group that data together. So say you have several different types of machines bringing in different types of network data, rather than having to search of all of those indexes individually, or a lengthy search where you're searching a wide variety of data. You can just group that all together in the network traffic data model and much more easily search that within SPL. In Splunk documentation, it provides detailed information about each of these data models and the fields that are recommended. This is very helpful for the normalization process, which we'll talk about in a moment. But it's worth noting that all of the data models that come in with the Common Information Model have a page in Splunk documentation that gives you a lot of very useful information if you're starting to work with that data model. But to talk about that, we kind of have to talk about normalization. And so this is kind of how it's able to group that data together in a way that's logical and useful. So you can see in this example here, we're getting data from Nginx, we're getting data from Apache. One has a default field name of source IP. One has a client IP default field name. They're both bringing in the same exact data, just under different field names. And we want both of those data sets to go into the web data model. The web data model wants you to use the field name source, SRC. So what we would do is, in this case, we would field alias and say, if the field name is source IP, make it be source. If the field name is client IP, alias that to source. So then both of those logs will come into the web data model and have that same data under the field name source. So normalization, it aligns fields of unique data sources to the Common Information Model standard names. It uses consistent fields that apply to multiple data sources mapped to data models. And it's generally achieved through either aliasing, like we talked about, where you create a new field with the expected name and you keep the content of that field. Or you can use eval, a common Splunk command, to create or overwrite a SIM field to match a set of expected values. So a good way to kind of think about this outside of the text sphere is local dialect versus common name at the bottom left there. So some people will say soda, some people will say pop. Pretty much everyone knows that you mean soft drink. In the same way that a vendor-specific name might be HTTP status, another vendor's name might be response code, the SIM data model will kind of bundle those together under just status. So that's kind of the data normalization process that's involved with data models, especially the SIM data models. And that's, once we go back to the documentation, how it says dataset name, field name, description, etc. This is how you kind of know these data model specific name they're looking for that you'll alias your data or your data field names to. And it is worth pointing out that because the Common Information Model is something that Splunk handles and maintains and recommends for all vendors that are bringing data into Splunk, if they have their own TA, something like that, all the vendors or many vendors use this Common Information Model to normalize their data within their TAs. So for example, like the Palo Alto TA, a very commonly downloaded one on Splunk base, will automatically start and do this normalization process for a lot of the data that's coming in so that you don't have to. You may have data sources that are a little more custom to your environment. They might not have a TA. If it has a TA, it might not have that SIM compliant data normalization. So there may be some custom or manual normalization process. It can be lengthy. It can be very, very manual and time consuming. But this normalization process, and especially the documentation, is very helpful in making sure that you know what to change the names to and start that data or normalization process and make it a little smoother for you. So we can go ahead and hop into a Splunk environment and get into the nitty gritty here. So this is my personal test environment. It is a pretty simple environment. I don't have a lot of data coming in. I don't have a lot of add-ons or anything like that. But I can show you here. So we can check data models. And you can see in settings here, we'll go to data models. I'm going to zoom in just a smidge here. And as you can see, if I switch to all apps, I only have 3 data models. One with Atlas, our custom application within Splunk, and then 2 samples. And so I do not have the Common Information Model installed in this environment yet. I can show you how to do that. And this is, again, for an all-in-one environment. I have Splunk base open over here. I searched Common Information Model SIM. we have our app here. We can get our details, installation, documentation. I'm going to go ahead and just click download. We're going to agree to download that. I can very simply go to Manage Apps. We're going to install this app from file. And that is not the right one. We're going to go to Downloads. We're going to choose the Common Information Model. We will click Upload. We're going to let this process for a minute as it installs into my environment. And then after this is done, we can see it was installed successfully. We can do SIM. We can filter our apps here. It's going to chug along here. And we see our Common Information Model app was there. So now if we go back to Settings and Data Models, we can now see we have 30 data models total. So if they're coming from Splunk SA SIM, that is a Common Information Model data model. So we have alerts, we have authentication, change, all those, that list that I showed before. We have all of those in here. Second page, we have all of those in here as well. And so now we have the data models here. If we go ahead and click on one, I can kind of show you how they are set up. And so you'll see this is kind of the default way that data models are set up. So you'll have root data sets. Some data models only have root data sets. Some have root and child. This one has root, child, 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 child of child, child of child, etc. So you kind of see the different kind of data that we can bring in. We can bring in, it's not just authentication data. We can split that out into different kinds of authentication data. So it's not just coming into one giant pile. We can split that out as we need to so we can get very specific on the data that we're bringing in. And you'll see all data models have constraints. So this one is very common for SIM data models. It'll start with a macro. The backticks here let us know it's a macro. This one's specifically looking for one named SIM authentication indexes. So we want to make sure that the data that we want to bring into this data model is going to match that macro. And actually, I'm going to jump into the data model that we will be populating, which is web. So here we have SIM web indexes macro. And then they also look for something called a tag. And you can tag data by using event types. And we can see here, if we go to a child data set, it will inherit the parent and constraints and add its own constraints. So if we feed data into the web parent data set, if we want to add proxy data, we would just need to add the tag on top of it being in a index that matches this macro and also having the tag of web. Same thing with storage. It'd have to match this macro, it'd have to have the tag web, and it'd have to have the tag storage. In here, we can see the fields that are within this data model. So we can see ones that are extracted, ones that are calculated. And this is kind of the same thing that we would see on the Splunk documentation website of this is what we'd want the field names to be if we were bringing data into this data model. So for example, if we had user is one of the fields in this data model, if we had one data source that had username as the field name, we had one data source that was source username, we want to bring both of those into the web data model, we would alias both of those fields to just match user. So let's see a little bit about what feeding data into a data model looks like. So I will show you here a little bit of test data that I have, or demo data, I should say. And that's, there we go. And so this is just some demo data. But we are going to say, for the sake of the argument, that this is two separate data sources bringing in similar data, but from two separate sources, and we want to feed this into the web data model. So we have our data here. It's in this specific index, and it's over two source types. And so the first part that we need to do, and I can go ahead and open up data models again, go to web, is that we need to make sure this index is pointing to our index. So if we go ahead and copy this, and we go to, actually, I think we need advanced search. So we went to settings and advanced search. We can click search macros. I'm going to go ahead and choose all apps. And we are going to find SIM web indexes. So as you can see, it has no definition so far. So we can go ahead and open this. We're going to go ahead and give it a definition of index equals testing 1. So it's going to go ahead, and whenever it sees SIM web indexes macro, it's going to go ahead and automatically put in index testing 1. And so we have step 1 set here. Next, we need to tag our data. And so we are going to open up here, settings, event types, and that's how we can apply tags. So if we go here, we're going to go ahead and create a new event type. We're going to say web data model practice. And we can give it a search string, and I'm going to specifically point out those two source types that we were looking at earlier in my index. And you can see it's asking for a tag. We can give it a tag of web. If we have data that can have multiple tags, so if it applies to multiple data sets within this data model, we can add multiple tags to this data. If we want to apply it to multiple data models, we could give it as many tags as we want in a comma-separated list of tags. So then we can go ahead and click Save. And if we go back to Search and Reporting here, this should be bringing data into our web data model now, because we've met the SIM web indexes macro, and we have the data tagged as web. So what we can do to check, we can do a from data model web command, and we can go ahead and run that. And you can see we are now getting data in this data model. And this data is, as you can see, we have these list of fields here. The data that's already coming in to this source type and index, whenever it comes into the web data model, it's going to look at its fields. If it has any that match these automatically or perfectly, it's going to go ahead and extract those in this search. So you can see we have a couple that match perfectly, and they're going to go ahead and be extracted in this search. So that is kind of the basic process of setting up a data model. And again, like I said, a lot of times TAs will do a lot of this work for you. It will likely be just a matter of setting the index, setting an event type to tag that data. Sometimes they even do that for you. And a lot of these evals or aliasing of the field types or field names will be done for you in TAs as well. But again, if we had data that was coming in that did not match one of these field names in the data model, we would need to start that normalization process and either eval a field or alias a field to match one of these. And one little thing I wanted to show you, that when searching or working with data models, especially SIM data models that are often used in enterprise security, there's a number of different ways you can search the models, but definitely recommend, if you can, to use T-stats. That is something that is heavily used in Splunk default correlation searches within enterprise security, but you can use those in regular searches as well, and you can use those in data model searches as well. So I'll show you one example here. And the reason we recommend using that is performance increase. And so we're going to run the search here. It's just from data model web. So we're looking for the web data model. And then we're going to count by status, the status field here. We're going to go ahead and run this. And again, this is just my personal testing environment. I'm not going to have a ton of data, so all my searches are going to run fast. But even on a small environment like this, I will show you the improvements that T-Stats can offer. So we can go to inspect job. It will bring up a screen here to tell us information about that search job. We can see it finished in about 2.2 seconds. Not too bad. But we can improve that with T-Stats. So we can take this search and convert that into a T-Stats count or a T-Stats search. And it's important to note that we have a previous data model that Steve has, or Steve put into chat under the Kinney Group account, that accelerated searching data model, or I should say Lunch and Learn. That one dives heavily into T-Stats. So definitely recommend that one, checking it out. It's very useful for production environments, making searches quicker and more performant. And again, doesn't have to be data models that uses T-Stat searches. You can use that with regular data as well. But working with data models, definitely recommend using T-Stats when you can. So back to my screen here, we have this T-Stats count. What I can show you, we had this previous from data model web, stats count by status. So here we did a T-Stats count. We give it the data model, and then we give it the data model field. So we had to do web.status. That lets us know it's in the web data model, and it's the status field. So if we run that, and as a reminder, this search took 2.2 seconds to run without using T-Stats. So if we run it, we'll get the exact same results in 1 second, just barely over 1 second. So even in a small environment like this, we can see the improvements. So if you kind of extrapolate that out to a enterprise size environment, you can really start to see the benefit that you could get from using T-Stats. And one last thing that I'll mention that's commonly used with SIM data models, especially in enterprise security, is acceleration. So if we go back to the data models page, you'll see a little lightning bolt in front of all of these data models, or in between all of these data models. That means, is this data model accelerated or not? And so you can see here, if we were to edit and then edit acceleration, we can get a button to accelerate this data model. We can tell it the summary range we want. So this essentially creates a summary of the data that allows for much, much quicker searching of that data. But it does come with a cost of storage capacity. So if you're summarizing a lot of data, it's going to require a lot more storage than just bringing that data in and putting it in a data model, because you're creating fast searching copies of those data. So you do get a huge performance benefit from accelerating, but you also have to kind of evaluate how that will affect your storage in your environment. And so I can choose the summary range that I want. And if I were to click save here, as you can see, this is now yellow. That indicates that this data model is now accelerated. And so to search accelerated data with T-Stats, you can give it the option of summaries only, and you can give it the value of true. And so what this means is that it's only going to search the summary T-Stats data, or summary web data model data. So as you can see here, I told it to give a summary range of 3 months. So it's going to only search data that has been accelerated. So if I run a T-Stats search, if I ran this over 12 months, it would only search those 3 months worth of data that it has accelerated, because I used summaries only equals true. So definitely recommend, if you start accelerating data models and start using tstat summaries only equals true, make sure your searches are at or less than the summary range, just so that you're not missing out on any data. And you're also getting the most performance for your value as well. And again, I doubt this will have much benefit on because it's not going to be summarized yet. But it is a very, very useful tool, especially in enterprise security, correlation searches, things like that, especially in very large environments. You'll get a huge performance increase if you're using tstat summaries only equals true on accelerated data models. And again, that is available for all data models, including Splunk SIM compliant data models. And I think some correlation searches even recommend to use summaries only equals true. So that is kind of the walkthrough of getting the SIM app into your environment, showing the different types of data models that SIM app offers, getting data into that data model, using the data model in searches, and how to search it a little bit more efficiently. And so with that, we can hop back over here and I can set up for any questions you might have. Feel free to put those in chat and we can answer them. And if you don't have any questions and you think of some at another time, feel free to email us at support@kennedygroup.com and we'll be glad to answer any questions you might have. Thank you for listening.
Thank you, Eric, for the information you presented today. As mentioned, there's a couple of links in the chat. So these are former or lunch and learn sessions we've done in the past that they're available on demand. So feel free to grab those links and take a look for some more information. Continue to add any questions that you might have to the chat on the topic today. We appreciate your time. If you have questions about our EOD services or our Atlas product, feel free to drop us a line as well. We'd be glad to answer any questions, even give a demo if you'd like.
And I see a question asking if there'll be a recording available. There is. After this session is done, you'll get an automatic email with the link to the recording. And if you want to pass this around to anyone else, if they sign up for the Lunch and Learn, even though it's already over, they will have access to that recording as well.
Okay, well, if there are no other questions, we will let you go back to your day. And I really appreciate your time and attendance today. Thank you very much.
Thank you, everybody. Have a great day.